Hello and welcome back. So we have understood the model building process, right? Total model building process. First step is to split the data into train test, then take the training set, then doing the EDA and feature engineering. Once the data is ready, that means all converted to numerical numbers. Then we feed it to a algorithm. Then we get a model, and we pass all x values and try to predict and then evaluate the model. If the model is underfitted, we'll do fine tuning. If the model is working good on train set, we'll take that model and try to feed the test set data, unseen data, and then make predictions and then evaluate and see whether overfitting is existing or not. If the overfitting is present, then we try to fine tune the model again and try to make the model more generalized. So let us see that whole process with an example. So I have imported the modules here, right? Pandas, NumPy, Matplotlib, Seaborn, and the linear regression. Scikit-learn linear regression is the new module, and scikit-learn model selection is a other new module we imported. From now on, we will use scikit-learn module. It's a Python-based machine learning module which actually has got implementation for almost all the algorithms. So let us import those and then import the data set. It's a bit huge data set. In a way we have huge in the sense we have 1500 records or so. So if you see the shape, right, it is giving you 1512 records and 13 columns, out of which one is the target variable. The salary is the target variable. If you look at the head, you will find the at a high level you can see what is existing there. The first step we need to do is split the data into train set, right? Train and test. So we are using shuffle split. In a way, right, what we are doing is we are taking the 1512 records and shuffling all of it and then trying to take 80% as the train set and 20% as test set. That is done by using shuffle split. The n splits is equal to 1. If you have to break a stick into two pieces, you need to make one split, right? So like that, we have taken one split and the test set size is 0.2, that means 20%. The random state is 32. The random state is like a seed in NumPy, right? If you don't set random state, what happens? I'll show you in a moment. But when you take the shuffle split and try to split the data, right, the data frame, it actually splits the data into train indexes and test indexes. It gives you the indexes which are related to which are going to be populated as train set and which are going to be populated or split as test set. Okay, using those indexes we are using LOC function to split the data into train set and test set. Okay, so let me execute this once and show you what happens. So here there are train set indexes are there and test set indexes are there. Train set indexes are more, that's where you got dots here. If you don't set random state, what happens? Let us see, right? If I don't set random state, let me execute this, right? I got 1029 1354 426. These are all indexes, right? If I execute it again, what happens? Let us see. See this 105 396, right? The indexes are changing. That means if you don't set the random state, every time you execute this file, the train set and test set will change. We are randomly picking the data from the data set. If you don't set the random state, every time you execute this file, the train set and test set will change. When the train set and test set changes or the indexes changes or the set changes, the training approach, the algorithm learning will change. When learning changes, right, the accuracy changes and it may not work as it worked on your machine or the first execution. The problem is like this. You have executed now and you have got 90% accuracy on train set and test set because the data was randomly chosen which is more appropriate for your algorithm. You took this to your manager and trying to show by running it again. You did not set the random state. So it would have chosen the train set in a different way. Now you got 60% on train set and 90% on test set. You will not have any clue, right? So the random state actually tries to fix the randomness of the train test split. How it exactly choosing the the indexes it fixes. The random state method, the attribute is present in most of the algorithms in scikit-learn. It is like seed, setting seed in the NumPy array. when I set the random state is equal to 33, if I execute, I'll get the same numbers, right? I'm executing again. See that? I'm getting the same indexes. That means the train set is fixed. The training is going to be fixed. The accuracy is going to be fixed. And the same way it's going to work on the test set also. So n number of times you execute, in production you execute, UAT you execute, a dev server you execute or show it to the manager or the client, it's going to be same, right? Random state should be set. That you need to remember. So we splitted the data. Now let us see how many records are there in train set and how many are there in test set. 303 are there in test and 1209 are there in the train set. As part of the next step we need to do is do exploratory data analysis and do feature engineering. Why? Because we need to understand whether there are nulls in the data set or quality issues are there, or how to convert the categorical columns to numbers or text columns to numbers, because machine learning algorithms, most of them, the tree based ones are okay with the categorical columns, but most of the algorithms will need numbers, because the machine learning internally is doing trying to find a mathematical equation. Mathematical equations work with numbers, so you need to convert all that, and then you need to you may have to combine features, and you may have to extract the dates from the date field, or things like that you need to do. So as part of the first step in exploratory data analysis, in data frame we have got a method called as describe, which actually shows you the numerical columns and their counts, right? In the train set we have got 1209 number of columns, rows, but here if you see the years of study, we have got 10991 only. That means there are some missing values. The count will show you the non-missing values or the non-null values. What is null in pandas or numpy? It is np.nan, right? So it will give you other details also: mean, standard deviation, minimum, first quartile, second quartile, third quartile, and the maximum. So when you look at this data, right, you will understand the distribution of data, right? How much data is distributed. And again, if you see this lines of code, the number of lines a person has written, you see there is a negative number in the minimum, right? That means it's not valid. Somebody would have written 0 lines of code, or maybe 10,000, 20,000 lines of code, but here it is showing that minus 784. That's a wrong data. So we may have to correct this problem, right? So we will correct it in the next video. Thank you.